Okay, ladies and gentlemen, this is the 3132 quiz review. I've already posted the answers to the review, worked out completely. It's in modules under chapter 3, so make sure you guys look at that. Also, watch the video, and if you have any questions this weekend, please email me. Your quiz is going to be on Monday. You'll have like 45 minutes, I think, to do. There's 8 problems, and you'll have a calculator, the use of a calculator, for about the last 15 minutes or so. So make sure you guys are well prepared. So let's look at number 1 here. If I'm going to talk about the domain and range, horizontal asymptote, everything of this function, I first have to identify that this is an exponential, okay? It's an exponential function, so I know in my exponential functions that my domain is always going to be negative infinity to positive infinity. I know that my horizontal asymptote is always going to be right here, whatever the vertical shift is, up, and down. So I'd have a horizontal asymptote at y equals -1. It's extremely important that you guys put x or y when we talk about the asymptotes, because if you don't, then we're going to have to take points off. Okay, let's talk about the transformations that are occurring as we look through here. I like to go from left to right. So I look right here. I have a negative out in front. That means I'm going to have a reflection over the x-axis. So our normal exponential function would look like this, but since it's going to reflect over the x-axis, it's going to go like this. So that's going to affect our range, because normally our range would be from the horizontal asymptote to infinity. In this case, it's going to be from negative infinity to the horizontal asymptote. The next transformation I see is right here up in the exponent. I have a +6. Since that is with the exponent, it's with the x, it's going to affect the horizontal axis. So this is going to be a horizontal shift, and it's going to go left 6. Remember, it's the opposite of what we think when it is with the x variable. So horizontal, and I'm going to go left 6. And then the last thing I see is right here, this -1 at the end. That's going to be my vertical shift, and I'm going to move down 1. Now for the last thing we have to do is find the y-intercept. And remember, to find the y-intercept, you plug in 0 for x. So I have my y-intercept is going to be at y equals negative. I have 2 to the 0 plus 6 power minus 1. So we evaluate powers first. 2 to the 6th power is 64. Then I multiply by that -1 in front, minus 1. I get a y-intercept at -65. So as an ordered pair, I would write, I plugged in 0 for x, and I got out -65 for y. Now coming over here and looking at number 2. Number 2, again, guys, this is an exponential function. So I can see that's an exponential function. That means right away I write that my domain is negative infinity to positive infinity. When I talk about my horizontal asymptote, remember, it's whatever is being added or subtracted here. Well, there's nothing being added or subtracted, so that means my function's going to get really, really, really close to the y equals 0 line, but not touch it. There's no reflection of any sort. It's a positive 1/3 out in front, so my range is going to be from 0 to infinity, and I use parentheses because it does not include. If we're going to talk about transformations, if I have a number out in front, that's going to be a vertical stretch or compression. Since that number is between 0 and 1, we're going to call this a vertical compression, or you can say shrink, whichever one you would like to use. Come along here, I have a negative that is up inside with my exponent, so that's going to reflect over the y. It's going to turn it like left to right, so it's going to go over y. I have a whole number 2 here. It's not a -2. The negative is the reflection. The 2 is the horizontal. This would be a stretch or compression. It's going to be a horizontal. We would think it's a stretch because the number is bigger than 1, but it's actually the opposite, so it's a horizontal compression. Or shrink, however you want to say it. And then if I have +1, again, that's with the exponent, it's with the x, so you would think it goes right 1, but it actually goes left 1. So we'll say horizontal shift, and we're going to go left 1. And then our y-intercept, again, guys, to find the y-intercept, you just plug in 0 for x. So you have 1/3, and then I have 2/3, -2 times 0 plus 1. So this becomes 1/3 times negative 2 times 0 is 0, so 2/3 to the first power. When we multiply this together, I get 2/9. So my intercept is going to be at, when I plug in 0, I get 2/9. Okay, in number 3 and 4, we're not talking about exponentials anymore, we're talking about logs. So remember, logs and exponentials are inverses of each other. So instead of my domain being negative infinity to positive infinity, with a log, it's going to be my range. And then when we talk about domain and vertical asymptotes, they go hand in hand. And the way that we find that is we set our parenthesis, our 4x plus 1 equal to 0. So I'm going to subtract 1 from both sides. I get 4x equals negative 1. Divide by 4, I get x equals negative 1/4. So my vertical asymptote is at the line x equals negative 1/4. There's no flips or anything like that, so I know that my domain is going to be from negative 1/4 to infinity. And then to find the x-intercept, we plug in 0 for y, which is our f of x. So I'm going to write log 3 of 4x plus 1 equals 0. Now, we've talked before, guys, we think better exponentially. So if I change this to an exponential function, this becomes 3. My 4x plus 1 moves to the other side, and the 0 becomes my exponent. So I have 3 to the 0 equals 4x plus 1. I'm going to move over here to do my work. So 3 to the 0 power is 1. So 4x plus 1 equals 1. I'm going to subtract 1 from both sides. So I get 0 equals 4x. Divide both sides by 4, and I get x equals 0. So when I plug in 0 for y, I get out 0 for x. So my intercept is at 0, 0. Moving over here, again, this is a logarithmic function. So I know that my domain is going to be based upon my vertical asymptote, and my range is going to be our negative infinity to positive infinity. Again, to find our vertical asymptote, we set our parenthesis equal to 0. So I'm going to add 7 to both sides. I get 2x equals 7. Divide by 2, I get x equals 7/2. So my vertical asymptote is at x equals 7/2. There's no reflections or anything, so I know my domain is from 7/2 to infinity. And then the x-intercept again is we're going to plug in 0 for y, which is our f of x. So you have log 2, 2x minus 7, excuse me, equals 0. Again, we think better exponentially, so I have a large 2. My 0 becomes the exponent, and my 2x plus 7 moves to the other side, minus 7, excuse me. So I have 1 equals 2x minus 7. I'm going to add 7 to both sides. And I get 8 equals 2x. Divide both sides by 2, and I get x equals 4. So my x-intercept is at the ordered pair. When I plug in 0 for y, I get out 4 for x. So it's at 4, 0. Okay, for these next set of questions, guys, there's actually 2 things you have to do. It says to rewrite in exponential form and to evaluate. So you should rewrite it in exponential and tell me what the answer is. So again, if I have log base 2, exponentially, I'm going to write a big 2. My 1/4 goes to the other side, and my x becomes my exponent. So I have 2 to the x equals 1/64. So now there's several ways that you can solve this. This would be my first answer as I rewrote it exponentially. Now if I'm going to solve this, what I personally would do is say 2 to the x equals 64 to the negative 1. When I bring that 64 up to the numerator, my exponent becomes negative. Now I look and I say, can I solve this using the 1-to-1 relationship? Can I make the bases the same? And absolutely I can. I can say 2 to the x. I can rewrite 64 as 2 to the 6th power, and then I'm going to just multiply that by the negative 1. Now that my bases are the same, I can cross them out, and I say x equals negative 6. So there's 2 parts to the answers for this question. Same thing here. I'm going to start exponentially to write it. I would say 81. My x would go to the other side, and my 1/2 becomes the exponent. So there is my exponential function, and 81 to the 1/2 is the same thing as saying the square root of 81, so I would say x equals 9. Over here, again, we're going to think exponentially, so I'd say 7, the x moves over here, 3 becomes the exponent, so 7 to the 3rd equals x. Should have done that in red. 7 to the 3rd equals x. That's our going from logs exponential. And then now as I solve this, I get x equals 343. 7 to the third power is 343. All right, this next section, it says solve using the one-to-one. That means what we have to do is get the bases to be the same first. Then we cross out the bases, set the exponents equal to each other, and solve. So in this first one, set up nicely for you. The bases are already the same. So I'm going to cross them both out, and I just say x plus 3 equals negative 6x minus 3. Move x's to one side and numbers to the other. I'm going to simply add 6x because I like variables on the left-hand side, and I'm going to subtract 3. So I get 7x equals negative 6. Divide both sides by 7, and I get x equals negative 6 sevenths. If you wanted to solve that, you absolutely could. Plug it back in for x at both exponents, and you get the correct answer. Here, I'm looking, and I say, okay, one-to-one property. Well, rewrite each number with the same base. So 9 is the same as 3 squared. So I can say 3 to the second power times my exponent of 2x. 27 is 3 to the third power. So I can say that times my exponent of 2x minus 4. Now that the bases are the same, bring your exponents down. So you have 2 times 2x equals 3 times 2x minus 4. 2 times 2 is 4x equals, distribute this, and I get 6x minus 12. X is to one side, numbers to the other, so I'm going to subtract 6x from both sides. I get negative 2x equals negative 12, so x equals 6. And again, plug it back in, it'll make your equation true. Same thing over here. I look and I say, okay, I've got to get the bases to be the same. As soon as I see a fraction, the first thing I do is I rewrite it with a negative exponent. Negative 1x equals 8 to the negative 3x plus 2. All right, now I can rewrite 4 and 8 as base 2. So 2 to the second power gives me 4, so I have to multiply by that negative 1x. And then I have 2 to the third power gives me 8, and then I multiply again by the exponent. Now that the bases are the same, 2 times negative 1x is negative 2x equals, distribute, negative 9x plus 6. I'm going to add 9x to both sides. 7x equals 6. Divide by 7, and I get x equals 6 sevenths. All right, lastly, guys, you're going to have 2 questions. It'll be one question, but there'll be 2 separate parts. One where you're going to have to compound the interest at a specific rate, like quarterly, monthly, daily, something, and then you're going to have to do one that's compounded continuously. So there's 2 different formulas. What I need to see from you guys is not just the answer. I need you to actually write down the formula that you used, and I need to see where you put all of the numbers to replace the variables, and then I need to see your answer. So when I see the word quarterly, I know that n is going to equal 4. So I have my formula is A equals P times 1 plus R over N raised to the NT power. Now I have to go through my problem and determine what all of these numbers are. So P, I'm going to use $24,500. That's the initial amount that I invested. My R, my rate, is at a rate of 2.7%. But remember, guys, 2.7% is not a decimal. I have to convert that to a decimal, so I would move my decimal point over 2. So my interest rate that I'm going to use to plug in is 0.027. Very important that you do that. N, we said, is going to be 4 because it's quarterly, and the time that they're telling us that we're investing over is 4 years. So that's my 4. So these are the things I need to see from you. I need to see that you understand the formula to use, what numbers you're going to plug in, and then I need to see you actually putting them in the right spot. So I have 24,500 times 1 plus. In your calculators, you need to have a double set of parentheses. So this would be 0.027 divided by 4. Close your parenthesis, and then raise it to the n times t. If you want to go ahead and multiply 4 times 4 and put 16, you're more than welcome to. If you don't, in your calculator, when you hit the end parenthesis and then there's a little caret button, you have to put 4 times 4 in parentheses. Make sure you guys do that. Once you get here, I don't need to see anything else other than A equals, and you tell me what your answer was. And this works out to be $27,284.27. Remember, guys, round to 2 decimal places because we're talking about money. So my next problem It says monthly. Everything stays the same except N in this case is 12 because there's 12 months in a year. So my principal was $24,500. My rate was 0.027. My N is 12, and the time that we're talking about is 4 years. So I have A equals P times 1 plus R over N raised to the NT power. When I plug in my numbers, I have 24,500. 1 plus my interest rate was 0.027 over, now I'm using 12, double parenthesis, and I can multiply these two together, or I can put my calculator 12 times 4, but it's raised to the NT, so it's to the 48th power. And then you just plug that in your calculator and tell me what you get. And I get $27,294.17. So guys, make sure you are ready. You can have 1 page of notes on your desktop or on your workspace at home. There's going to be 8 questions, and they're kind of involved. If you have to use your notes, hold on one second, baby. If you have to use your notes on every single thing, you're not going to have enough time. So make sure that you are prepared and ready to go. Calculator use can be for about 15 minutes at the end of the session. Email me if you guys have any questions.